Great, thanks, Phil. It definitely helps to have a resilient system when you're in the pub getting alerts as well. I was quite pleased about that. So yeah, thanks Phil. Thanks to Harry and Josh for inviting me to come up here and speak, to talk to you all about building resilient front-end systems. Something I'm quite passionate about, and hopefully that I can convince you all to go away and really care about on your individual products and websites. So I work at BuzzFeed. I lead the front-end infrastructure team, and we have an article for literally everything. So here's one about resilience. And hopefully this is the question that you can take away and ask yourselves at the end of this talk is like, how resilient are you to failure? How will your systems and your products work when not everything is correct? And this is also kind of the talk of how we learn to become resilient at BuzzFeed, because this has been a progress and we're still working on that. But I've been there 2 years, and throughout that period of time, we're in a significantly better place as a consequence of some of the things that I'm going to talk to you about today. So why resilience, and what is it? Well, I hope this font is big enough for everyone, by the way. So resilience is function in a hostile environment. And this is really important for us as developers, front-end developers, because the browser is a super hostile environment. We don't have many guarantees. We don't have a guarantee over the runtime. We don't get to control that. We run at support in different browsers. We don't have a guarantee over the amount of resources that your system is given to be able to work with. And also, we don't ship our systems as a complete package. We send different parts here and there, and we assemble it again at the far end. And all those things have to happen correctly for your system to work as you intended it to. So the way that we can think about building resilient systems is to understand, for your product, the tiers of user experience. What I mean by this is what's the most basic form of your site that you can ship that someone will be able to work with and be able to do what they need to do? And then what's the ideal situation, where something we usually design for first, where we're on a great device, we're on Wi-Fi, all that kind of good stuff. And then once you've evaluated those, you can work out the spectrum between them and build in different layers of enhancements so that you can have a better site. And resilience is about guaranteeing that most basic level. If you can do this, then you have a resilient website. But doing this is actually pretty difficult. It's pretty hard to guarantee that a user is always going to get that base level. So in this talk, we're going to talk about failure a whole lot. And we're going to split into 4 parts. So how our systems fail, how we can design for those failures, how we can mitigate risks to actually avoid some of these failures, and then ultimately how we can learn from the failure, because regardless of 2 and 3, we're still going to run into failure points. Our systems are still going to fail. We're still going to have to be able to deal with that. It's a lot of failure for one talk, but hopefully we can pick it up. All right, let's go bigger font. How do our systems fail? Well, lots of ways. And the first one we talk about is malicious interference. So remember, we want to guarantee this basic level of user experience. And for us to do that, HTTPS is table stakes, right? We can't be part of this resilience party unless we can guarantee that what we send to users is actually what they receive. And if we're not doing it over a secure network, then we don't have that guarantee. We don't have that control. So we need to be using that for anything to do with resilience. But having HTTPS isn't a guarantee that someone won't maliciously interfere with your content. And there's a really great example recently where a lot of government websites have this script running on their page, which enhances for speech, reading, translation for people who have dyslexia. And it runs on the majority of GovUK and lots of American websites too. And this was maliciously interfered with at the far end, to the point where it actually started running Bitcoin miners on your phone when you visited this site. So a bunch of government websites were interfered with, but they hadn't changed a thing. Someone had just changed the thing that we were referencing at the far end. And so this is something you need to evaluate in terms of your dependencies, and do you trust them? And script isn't the end of it. One thing we think about a lot is images. We use an image service provider to manipulate our images, to resize them, to change the content. And if someone managed to maliciously interfere with that image service and returned graphic images, not safe for work images, That's a big problem for us at BuzzFeed. All right. Another way that systems can fail, and usually quite catastrophically, is third-party availability. One thing I've learned at BuzzFeed is that the nines, like when people give you SLAs of like, we'll give you 4 nines, 99.99% availability, they're not to be trusted in any way, shape or form. And really they're just like they're a hope, and they're an artifact of the past, but not a guarantee of any kind of future. If you rely on these third parties, you need to be aware of that. And there's a couple of different ways we can think about these. The first is like a very obvious direct dependency. Like we rely on a script from some third party .js. And if that script doesn't load, if that site happens to be down, then our site is broken. And these ones are pretty easy to spot. These are very explicit, and if you have these, you need to be very sure that you trust this somethirdparty.com. Other ones are more implicit, and they actually need to dig quite deep to figure out all your dependencies. I'm not saying that we shouldn't have dependencies, by the way. These are obviously important, but we just need to choose who we do them with. So I joined BuzzFeed a couple of years ago, and soon afterwards, everything started breaking. And purely correlation, not causation, well, hopefully. But the first thing that happened is Dyn DNS went down. They suffered a distributed denial of service attack, and we were relying on them for our DNS. And it affected BuzzFeed for about 5 hours. We didn't have another DNS provider that we could switch over to at that time. So a lot of our pages were broken, as were a lot of the rest of the internet at the same time. Soon after, early 2017, S3 went down. You know that thing that never goes down, S3? Yeah, that one went down. That affected a lot of people, and it affected us for around 9 hours. There was a few, like, most of the pages were working for that full 9 hours, but we were in panic mode back at BuzzFeed. We also were kind of shipping a new version of BuzzFeed at the time, and had we been ready for that, we would have been in a much better place. But we shipped that soon afterwards, and then as these things tend to happen, an hour after we went to 100%, Fastly went down, or for us, just for us, for about an hour, which kind of really battle tested our new system and kind of had us fighting. And then later in the year, just for a bit of extra fun, S3 went down again for another couple of hours. This time we're in a bit of a better state. But this just goes to prove that we rely on these things for very good reason, but we can't guarantee they're always going to be around. And we need to think about what happens when they're not around, especially if it becomes a bad time for you and your business. All right. Another way we can break things is ourselves. Right? We're going to ship bugs. These things will happen. I'm sure we all have lots of tests. That's a good thing. Tests are there to protect us from releasing bugs. But our tests happen like within our environment, kind of at the edge of where reality happens. And then the reality part is the scary part, where browsers have different capabilities and our systems don't work exactly as we intend. So we need to make sure that we're monitoring in production and make sure that we're tracking these errors. For example, we use Sentry to capture our JavaScript errors. And these bugs do not appear in our tests, right? These are things that are happening in the wild. We need to be on top of these errors all the time. And having them in Sentry is great, but you'll soon find that people don't go and look at them, and they just build up. So try and be noisy and stick them where people do see them. For us, we send them to Slack, because people love being on Slack. And here you can see an error firing off, and people being, this is what happened to me in the pub the other day, essentially. This is hard, like figuring out that signal versus noise ratio of what I want to push to my developers and to wake them up in sometimes. And it's something you have to tweak over time, but it's definitely worth investing this time. And for us at BuzzFeed, this is really boils down to knowing it's broken before Twitter does. We have a lot of very engaged audience, people who are very happy to tell us when things are broken, which obviously we're happy about that, but I'm never usually happy when it actually happens. We obviously want to know ourselves beforehand. And when these incidents occur, we have post-mortems soon afterwards, and this is always the most interesting question to me, is like, how did we find out about this incident? Did somebody tell us, or did our systems pick it up? And if it wasn't our systems, that's really bad. We need to go back and fix that because we can't rely on our users to tell us. So one bug we did ship, which Twitter did tell us about, was to do with our images. I'll tell you about this one. So we tried to change something at CDN level for WebP images, which we just serve to Chrome, or well, to browsers that support them, but Chrome is the biggest one of our user base. So we made the change, we checked Chrome, great, WebP images are still working, patted ourselves on the back, and then lots of people just suddenly told us that it doesn't work in Safari, right? We accidentally broke all images for every user using an iPhone, which was pretty bad. We switched it back, freaked out, and then thought about how we're going to release this properly. But the thing is, when images don't load properly, they don't show up in Sentry. They're not an execution error. It's something we don't really have that observability over. So we built a very small system, which every time an image fails to load, we beacon off some data. And the graph looks like this. And then if we see a spike in this, then we know something's bad. And actually, this just helped us release it that first time, and now it sits in the background. And it's very useful when third parties go down, because this can inform us pretty fast. But to me, this was really interesting because we now had this system of beaconing back random instrumentation from the client, so we could think about how we can extend this to know more about the actual user experience that's happening at any given time, and not just hoping that it's working. All right, a fourth way in which things break is the network. So this is something that everyone has been taught in many, many talks, right? The network is flaky, we can't trust the network, we should think about ways to work around this and not rely on it being available. Something I'd also heard many times, but not something I'd ever proved or validated on our site. But now we had this system, right? So now we can actually track all our requests and make sure and see how many of them are failing and how many they're passing. So we extended those dashboards and started to look a bit more like this. So now we track when JavaScript fails to load, when fonts fail to load, and anything really, XHR requests, etc. This was very useful for us as developers working on infra, because we can see when things break catastrophically. It wasn't super useful for people outside of our team to really understand what was going on. There are errors happening pretty much all the time. Is that bad? Is that good? It's usually bad. But we converted that into something a bit more meaningful. So throw some percentages up. This is huge. And this is a great then tool for us to share with design and say, if these things do fail, we need to think about that. We need to plan for that. This is for just 1 hour. Over time, it averages a bit higher. But what we found is roughly 1% of our requests for JavaScript will time out. So if we're relying on these JavaScript bundles to be there to make sure our experience works at all, then we're saying goodbye to around 30 million page views a month for BuzzFeed. And that's not cool for us. We want to make sure that all those people get a working experience. We don't want to throw 30 million page views away. So that gives us impetus to build in a sort of progressively enhanced way and to think about those lower tiers and to actually go to product and say this is a requirement for us, that we can actually put a dollar value on it. And these big numbers have become a bit mundane as I've given this talk a few times, but the first time I saw this, I was a little bit blown away. Okay, so let's say all this goes perfectly, right? We don't have any malicious interference, third parties are all up 100%, no bugs at all, and the network is just zipping along. There's still one way in which it doesn't really matter, and that is the user's privilege, right? And roughly 9% of our users use some form of content blocker. And this has unpredictable ramifications on your system working. I used to work on a CMS for making adverts, and ad blockers would just rip parts of our DOM out. Anything that had a class name which said ad in it, that was gone. We had to switch it for fish at all points, just because otherwise you forget and then your system's broken. So it's unpredictable. It's not just getting rid of ads. Some other things may change. And it's also more than just advertising, right? It's content blockers. People can choose to extend these. And we see around 4% of our users won't get our fonts. So if we say 1% is our average for all requests, roughly 3% more, or 4x, is not getting our fonts. This is 40 million page views a month, and this is really bad if we're relying on fonts for the experience. If we're putting our icons in there, if it just doesn't degrade well, if we don't have our fonts, this is not a good situation to be in. And this is something that's really useful to share with design and to really get them to care about how these things go back. Right, so that's 5 ways in which our systems can fail. Quite a lot of ways. It's not easy to solve all these problems, but now I'm hopefully going to share some ways in which we can do that. But what are we going to do with all this, right? So one thing we could do is we could just hope for the best. And this isn't completely flippant. I do actually believe that it's not the worst thing to do. Sometimes your systems won't need to be 100% up. Sometimes you won't work on critical systems. Maybe internal tools, for example, and it's not worth investing in all of this stuff. However, if you can give a dollar value to every moment of downtime, you can start to think about how much this does matter. And if you happen to work on an e-commerce site where 50% of your revenue for a year comes in a period of between Black Friday and the holiday period, then you don't want to be in this situation at that point if something goes down then. And you don't want your boss calling you saying, why didn't we think about this? We just lost a whole bunch of money. So the other version of this would be to design for this failure. Rather than shying away from the fact that these things happen, owning it and saying we're going to make sure all these points are covered. So this is the second part. So how do we do this? A couple of ways. First thing we're going to do is we're going to prioritize the critical parts of the page. And this isn't rocket science. This is something we've all been taught as best practice for lots of ways. But if we look at kind of a typical dependency tree for a website, we make a request some HTML that has references to CSS, to JavaScript, some images, which have subsequent requests maybe, and some XHR requests to fetch templates and more images. We can see that there's a lot of failure points. Every single arrow here is an opportunity for this to fail. And each box is also a way for it to fail. And if the fully working user experience happens down here towards the bottom of the graph, then it's much more likely that this system can fail. What we want to be doing is we want to be pushing this up, ideally to that first request. That first request should carry a fully working user experience. And this is very possible for all websites. It doesn't mean that you just have to have HTML, but in that first request, we include the critical CSS, maybe any critical JavaScript that we need to actually do this. So for us at BuzzFeed, the most important thing is the article, right? We don't really care about this thumb strip up the top. We don't really care too much about the sidebar. We care about the content in the middle. So in that first request, if everything beneath it fails, it looks something like this. It's not going to win any design awards, but it's a user experience. It's something people can start engaging with and start reading. And this could be, you could argue this is much easier for a content-rich site that serves articles, and it definitely is, because we don't have to interact with that page. But I definitely believe it's possible to do this with any type of site. You just have to figure out what's the most important thing for your product and your system. If we look at the trainline.com, and we evaluate this product, the most important thing here is this form. They don't really care about the background or these offers down here. Those are nice to haves. But that first user experience should have the form in it. And that could just be an old school HTML form, or maybe you include some JavaScript, which gives it some extra functionality there. But that's the thing that should be there if everything else breaks. It's definitely achievable. You just have to prioritize. And the second way is starting to make our errors a first-class citizen. And by this, we don't mean talking about how errors look, designing error messages, designing states. It's about what happens when certain parts of our systems fail, and how do those failure states look like. For us, the way we sort of think about this one is something broke, should I tell them? Does the user need to know? Is there anything that they can do with the information that something broke? And usually it splits into two kind of easy parts. So if we take another article and we look at this, this news module on the right-hand side, this one here. This is requested independently from the rest of the page, and this can fail, right? There is backend systems that provide this feed. And if this box here fails, should we tell the user? You know, do they really care? Like, or can we just slide this up and pretend it never happened? Some very avid users of BuzzFeed will notice that, but they'll probably get over it. We should know as developers, but the user doesn't need to. We should be pinging back errors to our system to alert us that this is happening. If you take something like BuzzFeed CMS, which is completely public, by the way, anyone can go and make an article, which is terrifying from a security point of view. If this fails, we can't not tell the user, right? If they're trying to save something, we need to let them know. But we can still design that state. And, you know, we can do something quite bold, and we can say, oh, we're going to store this in, you know, locally to your device, and when it's back up, we'll fix that for you. And these are all decision points that we can spend time with design thinking about how these things degrade. Okay, so 2 ways to think about how we can actually design for that. And the next part is mitigating risk. But the reason this comes afterwards is because the design part is still more important. This is only going to mitigate the problem. It's not really going to solve the problem. You're always still going to have these failure points. But mitigating is pretty good. That is something that's nice to have in your back pocket. You don't, when these things go down, if you can completely avoid it, you're going to be in a much happier position. So the first way we're going to talk about is locking your runtime dependencies. And for this, I want to point back to the original one where we had a simple request to a third-party JavaScript file that you're relying on for your system to work properly. Now, you have no guarantees over what's returned from that file. Even if you happen to have a version in that URL, anything can be changed at the far end, and you're going to blindly execute it. And this is something you wouldn't typically do if on like a package.json file. You'd think about how you handle these dependencies. But in the browser, we're a bit less in control of those kind of things. And because the user system can change underneath us, it's a lot easier for us to guarantee resilience if our actual code can't change as well after you've deployed it to production. So there's something new in the CSP spec, Content Security Policy, which allows us to lock this down a bit more. And that's this integrity hash. And what this means is that if the returned content of the file does not match this hash, which we've predefined, that we just won't execute it, and we'll just forget about it. And so this allows us to actually lock these dependencies down to a specific point. The third parties you use probably won't like this, because they can't then ship updates to you all the time, which is a new problem that you're going to have. And that you just have to build in a process for how you're going to solve that. But we're trying to roll this out to all the third parties that we have on BuzzFeed, because we believe it gives us a better opportunity to be safe. And you don't want to be in that position we had earlier where suddenly you're mining Bitcoin for all your users. Lock them down. All right. Next thing is building in redundancy. This is by far my favorite bit. Like, all these third-party dependencies we have, like, you should analyze all of them and make sure you have 2 of everything, essentially. This is can be expensive in some ways. Some ways it's quite cheap and you can get around it very easily. But you need to think about this for every single one. The hardest part is actually finding all your dependencies. Usually that's quite tricky. So we'll talk about a simple redundant server. And we'll use an asset server as an example, just because I'm permanently scarred by S3 going down. So let's say we make a request to this asset server, assetserver1.com. And this server is unfortunately down and on fire. From this, we cannot return a response, right? There's nothing coming back. So the user stays with their white page and they get frustrated and they go to a different website. In a redundant system, we have a second asset server over here, and we can flip those requests over to a new domain, assetserver1.com, assetserver2.com rather. That server's running fine, not on fire, so we can return some CSS, the page gets painted. This is called an active, inactive system. And it's not bad. We have this for a few of our dependencies. For example, our image service, we have this, which went down the other day, and we managed to flip it over to S3 and only had like a few images that were actually affected for less than a minute. But there's a couple of things that isn't so great about this active inactive system. The first is it requires some manual intervention, typically, to actually press this kill switch to switch us over to a new setup. And the second thing is we don't really have much trust in Asset Server 2 because it's never being used in production. If Asset Server 1 is at 60%, 70% availability, then you have to be pretty confident that number 2 is going to work fine before you switch it over. So it's better than nothing, but it can still be quite scary. An alternative approach is to stick to one domain. Just send this one to assetserver1.com, and that's just your only server. Behind the scenes, you're then proxying between 2 different services, and you're sending 50% of the requests to one and 50% to the other. This means that these are both being tested in production all the time. And we can guarantee, hopefully, that one of them goes down. One of them will return. This is the setup that we have for our assets. We have one being S3, one being Google Cloud. And this was implemented after that first S3 failure. And you can extend this for lots of other things. Like I said, we used it for our image service. But you might have A/B test services that you use to switch experience, and if they go down, you're in a bad situation. You could have another version of that. And you could take it as far as you like. You could have your whole cloud infrastructure, which is something some companies do. They can just switch across if there's a big outage. And we take it maybe even a step further, and we have something we call Plan Z, because it's an American company. And this is kind of our like break the glass, everything is on fire situation. And this is a fully static representation of BuzzFeed.com, which sits in both S3 and Google Cloud. So that if our CDN's down, if DNS is down, all this kind of stuff, we can switch it. Well, actually, we didn't need DNS. If everything else is broken, we can switch at the DNS level and not point to any of BuzzFeed's servers and just point to S3 or Google Cloud. We've never actually had to use this. It was a huge engineering project which will probably never be used, but it's extremely nice to have. And we can switch on whenever we need to. Probably you don't need this, but you never know. If you're using a purely static site in the first place, actually doing that might be very simple. For us, it's a bit trickier. All right. Another way we can build in resilience is by getting comfortable with serving stale content. So stale content is basically a version of our site that is not completely up to date, is not the freshest, and doesn't come from our servers directly. So if we look at this again, for us to be able to serve stale content, we need some kind of intermediary between the browser and our servers. So let's say, for example, that's our CDN. And when a user requests something from us, it goes to the CDN, and then we return that content to the CDN, and we say, you can serve this for a year, a day, an hour, whatever it might be. And if we get another request for that, don't bother us. So we send that back to the user with those headers, and they get a page. Next time they make a request, the CDN is just going to return it straight away. But one of the nice things you can also configure with this is to say that, even if that day has expired, let's say we said you can have it for a day, but we're on fire, just keep serving that super old content. And this is something you can configure with most CDNs. And this is incredibly useful when things are on fire. So that next request comes in, doesn't matter even though we're down. The best thing about this is it takes the pressure off you when things are broken. So when you're actually responding to an incident, responding to something being down, it's usually quite a stressful situation. Tensions are fairly high, and if you know that users are still getting their content, it just takes that pressure off and you can make better decisions about how you can fix the actual problem. This is super useful. So what if this first request fails, right? We know 99% of our requests are going to be fine, but there's always going to be some which break. So if we don't even reach that CDN, we can't return anything, right? Well, we can stick a service worker in there, and we can call that another form of stale content. And who knows what we can put in there. We probably can't have the same amount that we have at CDN, but we can still intercept that request and we can serve something. Maybe we have an article of the day, maybe it's the same article they're refreshing, maybe it's just a quiz. But this is something that we're happy to serve that is like nothing to do with our actual servers. As soon as you introduce these intermediaries, you create new problems for yourself of how to invalidate these caches, but that's a separate thing. I'd still rather be in this situation. All right, 3 ways to mitigate the risk. If you do these 3 things, you're going to be in a very good place. But it's still going to go wrong. It's definitely still going to go wrong. And from that, we need to learn from these mistakes. You can't predict all these points of failure that you have inside your system, so you're inevitably going to be in this point. So the first way we do this is by running postmortems. These are meetings that we have after any kind of sizable incident, and we take these as opportunities to see how we did. The most important thing about this is they're blameless. When S3 went down, it was because a developer had put in a terminal command which actually blocked access to S3. You could argue that was their fault, but there's a much bigger argument that says it's the system's fault that allowed him to do that in the first place. So if you can frame in that way, it gets you much further in these meetings. The things you want to be thinking about are like, how did we handle it as a team? How did we respond? Were people awake? Were people in the right time zone available? Did the people who had the knowledge, were they able to share it, or was it documented in certain ways? And how could it have been prevented? If we'd had redundancy, would this have been a problem? And should we have had redundancy? After that S3 incident, we were down for we were affected for 9 hours. The post-mortem after that lasted 3 hours, and there was about 30 actions we took away from that and ways in which we can make our system more resilient. And we didn't know about any of those things until it happened. This is always the way that it goes, pretty much. So it's really worth spending this time to make sure you actually go through the full flow. And the second time S3 went down, because of that, there was 0 impact to our users. All right, the second thing that we can do to learn is to run fire drills and chaos testing. Now this is getting quite far into ops world now, but incidents are stressful, they are full of tension. So if you can create a safe space to practice these things, then you're going to be much better to respond when it actually does happen. So fire drills are something we can do just to simulate errors happening and see how we respond as a team, and see how the dynamic works for how we set up communication within those things, particularly if you're in remote teams. And it's really hard to learn these skills unless you're put in this situation. These are the 3 things I've kind of learned about how to run incidents, which I will just briefly mention, but the first thing is to limit the impact of this incident. And sometimes that actually might mean sacrificing a system so that other systems can still keep functioning. But that's the first point of call. Second thing is just being decisive. Making that decision to shut down a system is a really difficult thing to do, but delaying that arbitrarily is much worse. And delegate early. If you're the one that's running the incident, you can't be the one that's fixing it, so you need to delegate that responsibility to other people. One of the best things you can do to sort of get to see people doing this really, really well is to look at some air traffic control videos on YouTube. And the way they handle things is incredible. They just they keep the pilots at ease when things go wrong. They manage it perfectly, and they very often save lives. And chaos testing is just fire drills, but with real fire. You're deliberately introducing failure into your system to make sure that they're resilient. And this is something that was coined at Netflix. They had a tool called Chaos Monkey, which brought down EC2 instances and saw how you responded to them. But it's something you can implement in other ways in your system too. And essentially, this is just introducing failure so that when it does happen, your systems are already prepared for it. All right. So these are ways we can learn from our mistakes. So I just want to summarize what we've been through because there was a lot. And this is, perhaps an alien sort of subject to a lot of people. It certainly was to me before I'd gone to BuzzFeed. But the main thing you can take away is to know what's important to your users. Really think about your product and what's the main point of it and how you're going to guarantee that. Try to identify how your system will degrade and think about whether or not those degradation points need attention from design, attention from engineering, and that users can still have something. And take this time to identify your points of failure. We found out a lot about our points of failure from them failing, which is much worse than you figuring out beforehand. You'll all have them in your systems. We definitely still have some. And when they do go down, make sure you learn from all of them. Take that time to actually spend with your colleagues to figure out what could have been done better and how you could have avoided it in the first place. Outages are inevitably going to happen, so you might as well make the most of them. Thank you.